Bismillahirrahmanirrahim. In this question, we have to determine some parameters, beta technological parameter, Kp, C oxide, T oxide, and L minimum for square submicron MOSFET technology working in ohmic region. Here you will see that no numerical value is given here, but three information is given, which is sufficient to solve the whole question. One is square submicron. Square submicron. Submicron means that less than 1 micrometer, and we assume 0.35 micrometer technology of the channel length. Technology always defined on the basis of channel length. And another important parameter they give is square. Square means that thickness, length, and weight more or less constant. And W is equal to L because it's very small channel length. So we assume that thickness and length is more or less nearly constant. So now we have to determine these all parameters. And because we are using 0.35 micrometer channel technology, so it is rule of thumb that R on is equal to 3.4 kilo. And another important information the question is provided that the MOSFET is designed in ohmic region. Any MOSFET whole is life working in the ohmic region. So that's why we use the R on is equal to 3.4 kilo ohm because it is standard rule of thumb that when some micro R on is equal to 3.4 kilo ohm. So first parameter is beta. Beta is just a proportionality factor, and we defined in our previous unit that R on is equal to 1 over beta VGS minus VT. So R on is equal to 3.4 into 10 power 3 ohms, and VGS minus VT, this is another important parameters that in 0.35 technology, 0.35 micrometer technology, VGS minus VT is approximately 1. So that's, in other words, the difference between threshold voltage and gate to source voltage should be very close to the 1 to 0.35 micrometer channel, 0.35 micrometer channel length working in ohmic region. So that's why we replace VGS minus VT by 1. And in this way, beta is calculated, and beta is equal to 2.95 microampere per V square. Now the another parameter we will determine, which is Kp technological parameter. And as we know that when micro MOSFET work in ohmic region, so beta is equal to Kpw over L. So here, because we are using square um, MOSFET, so W over L is 1 because W is equal to L. So beta is directly proportional to, then beta is exactly equal to the Kp. And so that's why the same unit of the beta will also use the same unit of the Kp, and Kp is equal to, is also equal to 95 microampere over V square. Up now, the third part, we are interested to determine the capacitance of the oxide layer. And capacitance of the oxide layer, we have very good relation between technological parameters is equal to the mobility of the and C oxide. And C oxide we have to determine, and Kp we have already determined. But important thing is that mobility of the electron, and for n-channel MOSFET, mu n is equal to 600 centimeter square per volt per second. We are using an mobility of the electron because our from the figure it is clear that our source is n plus and type, and our destiny, our train is also n type, so channel is also n type. So that's why we can say that C oxide mobility is equal to simple 600 centimeter square per volt per second. It is constant for the silicon. So that's why we will determine the C oxide, which is equal to the simple way Kp over mu, and Kp is equal to 295 into 10 power minus 6, and mu is equal to 600, which is mobility. So C oxide is equal to 4.9 into 10 power minus 7 farad per centimeter. Now the Fourth part, we are interested to thickness of the oxide. And once you determine the C oxide, we have very good relation. T oxide is equal to epsilon oxide over C oxide. Epsilon oxide is a dielectric constant, and it is for silicon, it is equal to the 0.34 picofarad per centimeter. So that's epsilon oxide is a silicon oxide because insulator is used as a silicon oxide, not silicon. So for silicon oxide, dielectric constant is 0.35, 0.34 picofarad per centimeter square. And then C oxide, we have already determined 4.9 into 10 power minus 7. So our T oxide is equal to the 7 nanometer. Now, important thing that we assume that we use the 0.35 micrometer technology is mean that channel length is 0.35 micrometer. Now we check that, and we can easily check that because it is rule of thumb for the submicron technology and particularly 0.35 micrometer technology. T oxide is equal to L minimum divided by 50. It is yani T oxide is a 1/50th part of the um, channel thickness. So in this way, when 50 multiplied by T oxide, we have calculated 7 nanometers. So our channel length is equal to the 0.35 micrometer. So in this way, we very little information is provided because but we use the standard 0.35 nanometer technology, and it is working in the ohmic region. We can calculate it many parameters like beta and technological parameter, capacitance of oxide, thickness of oxide, and the thickness of the channel. Thank you.